Hey, hi everyone, how are you? In this video, we are going to solve the lead code problem of the day, and the problem is count subarrays where max element appears at least k times. Now, the question category is of medium level, but I would say if you know about the sliding window algorithm and two pointer technique, then you should be able to solve it very easily. This month, the lead code problem of the days are mostly on counting the numbers and counting some data in a array and subarray. And most of the time we are trying to implement the same algorithm, sliding window with two pointer technique. So this is going to be very similar to other solutions which we have already seen. The input in the given problem is an array of positive integers. Let's call it as nums, and another positive integer, which is k. The output which we need to give is the number of subarrays where the maximum element of nums of your given input nums is at least k times in that subarray. Well, the question description is too long, but it is very easy to understand. You are just given two inputs, an array of positive integers nums and another positive integer k. You need to find out how many subarrays do you have in this particular array such that the number of times the maximum element of your array nums appears in your subarray is at least k times. Now this might sound confusing, let me clear it. If this is your given input and this is the value of k, the output in this scenario will be 6. What is this 6? This 6 is the number of subarrays we have in our array nums such that the maximum element of nums appears at least k times in those subarrays. So there are 6 subarrays in this particular array such that the maximum element, which is 3, right, in the array, in the given array nums, the maximum element is 3, right? So we have total 6 number of subarrays in this given array such that 3 appears at least k times, that is at least 2 times in those subarrays. Now what are those subarrays? This is the first one, 1 3 2 3. That is 1 3 2 3 is a subarray in which the maximum element of your array nums, that is 3, appears at least 2 times. So in this subarray we have the max of nums, that is 3, 1 and 2 times, right? And the value of k is 2. So we can say yes, this subarray has at least 2 times or at least k times the max element of nums, right? So we have 1 3 2 3 and then we have 1 3 2 3 3. This whole array is also like a subarray, right? And the number of times we have 3 in this is 1 2 and 3 times, right? We need at least 2 times. So this array also satisfies the condition, and we can say this is also a subarray with max element, that is 3, appearing at least 2 times or at least k times. So we have 1 and we have 2 subarrays, and we have another subarray, that is 3 2 3. We have 1 and 2 times, right? The number 3. Then we have another subarray 3 2 3 3. We have 1 2 and 3 times, which is more than 2, right? And then we have 2 3 3, this particular subarray which has 3 at least 2 times, right? 1 and 2. And then you have another subarray which is just 3 and 3, in which we have 2 number of times the number 3. So we have got total 6 subarrays in which the number 3, which is the maximum in the nums, appears at least k times. Now this question, if it seems confusing to you, let me just tell you that this is very simple to solve. You just need to know about sliding window and two pointer technique, okay? So if you know about these two techniques, then this question is going to be really easy for you. Now suppose you don't know about this algorithm, then how can you solve it? You need to solve it in brute force, right? So you will have to generate all the subarray in your given array, and in each subarray you will have to check how many times this number 3 or the maximum number appears in your subarray. If it appears at least 2 times or at least k times, then you will count it. And the best you can do in brute force is O of n square time complexity. But we are going to solve it with O of n time complexity using sliding window algorithm with two pointer technique. What we are going to do is, if this is the given input and the value of k is 2, so first of all we will find what is the maximum number. We can do it in a single loop, right? We can just loop through our array and find the maximum element, which is 3. Now we are going to use two pointers, the left and the right. Both will point to the same element in the start, that is the index number 0, right? So we have 5 elements, 1 2 3 4 5, and the indexes are 0 1 2 3 and 4. So this is the starting, or this is the initial element in our array. So let us say the left is 0 and the right is 0. Then the sub array will look like this. It will have just one element, which is 1. Now the moment you start looping through your array, what you will do is you will keep this left as 0 and you will run a loop in the right, okay? So right will go from 0, then 1, then 2, then 3, then 4. So you started with 0, that is your left, and then you have the right here as well. So you got to have one subarray that contains one element, that is 1. Now the total here is 0. What is this total? This will count how many times do you have this maximum element in your subarray. So every time we are going to either add an element to our subarray or delete one element from our subarray. So if we will add an element, then there is a chance that if we add the element 3, then the total will increase by 1. And if we remove an element, and if we remove the element 3, then we are going to decrease the value of total by 1. This is what we are going to do. So initially the left is 0, right is 0. I can say, okay, this is my subarray and the total number of 3 I have is 0. So is this a valid subarray? Do you need to count it? No. We need at least total should be 2, right? K is 2, so total should be 2. That is, we should have at least 2 number of 3s in our subarray. And we have 0 in here. Next, what we need to do is, since we know that this subarray is not fine, it doesn't contain at least 2 number of 3s, then we need to add an element, right? So we will add the next element, which is 3. That is at index number 1. So we will say the left is 0. Don't change the left, but increase the right pointer. So left is 0, right is 1. So at this point of time, our subarray is 1, 3 and our total is 1. Because the element which we just added is 3 and that's equal to the max. So if it is equal to max, we are going to increase the count of total by 1. So after processing this, we will have this as a subarray, left and right at 0 and 1, and total number of 3s in our subarray is 1, which is still less than k equal to 2. So we still have not got a subarray which is valid. So we need to add another element. So left will be 0, index number 0. The right will be index number 2. So left is 0, right is 2. Our subarray is 1, 3, 2, right? This is our subarray. We just added an element which is 2 and that's not equal to the max, or that's not equal to 3. So we are not going to increase the count of total and total is still 1. Okay, fine. Let's add another element. So our left is at index number 0 and right is at index number 3. This is our subarray 1, 3, 2, 3, which is this one. Now I just added an element which is 3, that is equal to the maximum, that is 3, right? So again we need to increase the total. So the total was 1, now it will be 2. So we got a subarray which has at least 2 number of, or at least k number of maximum element, that is 3. So we have 1 3 here and 1 3 here, right? So we will count it. This is a valid subarray which we need to count. Now here is the one very important thing which you need to understand. If our left pointer is at 0, right pointer is at index number 3, and this is our subarray, and this is valid. Now if this is a valid subarray, if I will add one element to it or more elements to it, all the arrays or all the subarrays are going to be valid. Because if this subarray 1 2 3 4 element subarray has at least 2 number of 3s, so I am sure that if I keep adding more element, then the number of 3s are at least going to be k, or at least going to be 2. It is not going to decrease, right, if you just keep adding elements. So at this point of time, I will say that if this is my complete array and at this point I got a subarray which is valid, then I can increase or I can change the subarray just by adding one element. Now this is another subarray. If we would have been having more elements like 1, 2 and 3, we would just increase the size of our array and that's going to be another subarray. So the point here is, if this is a subarray, then I got one subarray, but I can just keep adding elements and I will get more subarrays, right? So I have a subarray 1 3 2 3 and I have a subarray 1 3 2 3 3. I don't need to check if the total is at least 2 because I'm just adding more elements. So the total can increase but will never decrease. So at this point of time, how many subarray have I got? It is very important to understand that the index is 0, 1, 2, 3 and 4, right? We have total 5 elements and at index number 3, I got a subarray which is valid. So I would say I got a subarray ending at index number 3. I got another subarray, or I will get another subarray ending at index number 4. So all the indexes before this number 5, that is index number 4, index number 3, will be valid, right? So the formula is n minus right. N is the length of your array. N is 5. Okay, you have 5 elements. And the right index where we got the subarray which is valid is right index is equal to 3. So I would say 5 minus 3 is equal to 2. This 2 means that I have got 2 subarrays which is valid. The first one is 1 3 2 3. The second one is 1 3 2 3 3. These are the 2 valid subarrays. Again, you need to understand the formula. Let me explain you again. At this index, I got a subarray starting at some point 0 or 1 or 2, doesn't matter, okay? What matters is it is ending at index number 3. So I can just add one more element and I can say I have another subarray starting at whatever point, starting at 0, 1, 2, doesn't matter. I have got one subarray and I have got another subarray. What is the formula? The right is here, n is equal to 5, that is the length. So I can say between this right and between this n are all my subarrays, right? So I have this 1 and 2. So I can say n minus r is my formula to know the number of subarrays. So at this point of time, I will have 2 subarrays which is valid. So let me write it. The current answer is 2. Now the next thing is, do you want to increase the value of r that we are doing till now? No, not as of now. What we are going to do is, we are going to play a trick. If this is a subarray which is valid, can we just remove the leftmost element and check if this subarray is also valid? Let us try this, and this is what we need to do. Left pointer will increase. Once you got a valid subarray, this time your left pointer has to increase. It is 0, it will be 1 now, and the right pointer will be 3. So your subarray will be 3, 2, 3. Now the total, will it decrease? So we removed an element which is 1, that is not equal to 3. So there is no change on total. So from here we can say that this 3, 2, 3 is also valid. So how many subarrays we have got? Since the value of r is still 3, I can say n minus r, which is equal to 5 minus 3, which is 2. I got 2 more subarrays. What are those subarrays? 3, 2, 3, and I can just say 3, 2, 3, 3, right? So I got 2 more subarrays. I already had 2, so I would say 2 plus 2, and that's equal to 4. So I got 4 subarrays till now. Again, let us do the same thing. Since we got a valid subarray, I will say L was 1. L, the leftmost index, will now point to 2. So now the subarray is 2, 3, right? So this is L, this is R, this is 2, this is 3. So the subarray is 2, 3. We just removed an element 3, so the total will decrease, and that is equal to 1 now. We need at least 2 3s, right? So this is not valid. So at this point of time, we are going to increase an element in our array. So now L is 2, R is 4, the subarray is 2, 3, 3, and we added an element 3, so the total is 2 now, which is valid. So now R is 4, N is 5, so we got 5 minus 4, 1 subarray, right? So at this point of time, I already had 4 subarrays. Now I have 4 plus 1, 5 subarrays, and then I can say, okay, once we got a valid subarray, I'm going to increase my left pointer, and this will be 3 now. So this is my subarray now, 3, 3. So we just removed an element which is 2, and so I can say the total will not decrease because we didn't remove the element 3. So now the subarray is 3, 3, the total is 2. We are going to count it. The count was 5, now the count will be 6. 6 because at this point right is 4, the formula is n minus r, it is 5 minus 4, we got 1 subarray, we had 5, so 5 plus 1 is 6. So the current answer is 6, and again we will just remove the leftmost element. We will be left with one element, that is 3, right? L is 4, R is 4, the subarray is 3. At this point of time, total will be 1 because we removed an element 3, and now we cannot add any more element because now we don't have any more elements left. So the final answer is 6. So that is the output. 6 is the output. And that's the complete explanation of this particular problem and the approach to solve it. So let me take you back to the code editor and show you how the Python code will look like. So we have just calculated the maximum value, which is mx, then the left index is 0, result is 0. Result means this is the variable where we are storing the number of subarrays. Then the total, this total will be 0, that will store the number of times we have seen the value of mx, and then n is the length of the array. Then run a loop for right in the range of n and increase the value of total. So total will be equal to total plus nums of right equal to mx. So if the next element coming is equal to mx, then this value will be added as 1 and total will increase by 1. But if it is not true, then this will be 0. So total will not change. Now, while the value of total is more than or equal to k, it means that our subarray has at least k number of max element mx. Then the result is going to be result plus n minus right. That's the formula, right, to find the number of subarrays. Now the total is equal to total minus, let's remove the leftmost element. So I am going to say, if the leftmost element is equal to mx, then decrease the total by 1, else keep the total, because this will be 1 in case it is true and this will be 0 in case it is false. And then we increase the value of left index. And that's the complete logic. You just need to come out of the loop and return the value of result, and that's the complete solution for this particular problem. You can just submit this code and this code will be accepted, and this is actually a pretty efficient solution for this particular problem. So yes, we have solved this particular problem as well. And that's it for this video, guys. If this video helps you to understand the problem and understand the solution approach as well, then make sure that you hit that like button. And if you have not subscribed to my channel as of now, then make sure that you subscribe to the channel as well. And I will see you guys in the next video. Thank you for watching this video, guys.